We start with a normal H alpha channel. This is about 6 hours of H alpha. This is Pac Man Nebula 281, and there's a beautiful dark nebula and there's very dim, beautiful shapes in here, as you can see, the pillar-like formations. This is the full-size TIFF file. This is not reduced. So first I always make a duplicate image from the original here. And even some of you are using PixInsight or something software like that. Same principles are doable in different software. So I'm using Photoshop, but it's not necessarily have to be Photoshop. And then I make a second layer for this. And now you have done this perhaps many times, but I do it from the scratch, the star removal here, and explain why every step is done. I'm using dust and scratches, and then I pick up from the image something where is some bright detail, like a tip here. And I place the radius. Let's say in this size, stars are not very big. I use 15, and set threshold so that this detail doesn't go away. You can check it here. Not yet. No. This looks good. Only stars are. You don't have to be extra careful, because you will see that all the mistakenly removed parts are going to be back there. Okay, that's the first round of iterations. Second. Second. I put the radius smaller, let's say 9, from 15 to 9. And same thing, I select the bright point. Looks good. Again, third. Let's try 5. 9 to 5. Now I don't want the picture to get soft, like now. It gets soft. So I back off a little. This looks good. Okay. And now the fourth iteration with dust and scratches. I lower it down to 3. The lowest radius, usable radius, is usually same as the star size. So if you have good seeing, you can go down to 1, but if you have average seeing, maybe 3, 4. Now this image has around 3, the star size, so I go down to 3, and now I change the threshold again, and check a couple of points here. It looks good, and you can see some dark details are missing now. If I go close up here, and I blink, you can see there's some dark parts are not badly, but a little bit. Like here, like this one, it's missing now. So I take a copy from the image with stars and bring it front and turn mode to darken. So now only dark details are restored back. As you can see, there's. If I go very close point, you can see the dark noise is coming back. Here is the dark noise. It's coming back. So now there is a few brighter stars here. So not too many. I just use a heal tool, or you can use a copy or whatever you like to get rid of them. This is not actually a very necessary step, but if I want to stretch the image, the bright spots are disturbing. So I just pick up a few brighter points away here. It's a couple of clicks. Let's see, there's a couple of more. Let's couple of more. Okay, it's good enough. I want to make another copy of this because I'm using this as separation map, and I want to keep the original. I always say this image is actually just a stretched stack, calibrated files. I always say many times, but to work this method, all the original raw files has to be perfectly calibrated with flats, bias corrected flats, least. So there is no, and there can't be any gradients. Otherwise, you dig just gradients out. So if there's a gradients, I use something like a gradient terminator or some other software to flatten image. So I make another copy here. And I'm using this. Now with starless image and image with all the data. And now this image will be subtracted from this image. It leaves only a difference between those two images. And it's done under Photoshop, it's done here. Apply image. And then you select mode, subtract. And the name of the image was that for some reason it gives me this offset. Okay. Sorry, I did it wrong. This is image HA, yeah. I subtracted wrong image, sorry. Apply image HA here. And these values must be like this. Offset has to be 0 because it was, for some reason, it was something else. Its default value is 0. And okay, now we have image where it's just stars. But if you look very carefully and very close here, you can see there is stars, but there's noise. Can you see from there? It's a little bit bad contrast here. But if you look carefully, I stretch this here, so you will see there is noise. Can you see now? This is noise all over here. Those dots. Not much, but there is noise. Okay. This is image with stars, and actually this is image with stars and white noise. The black noise is in other image. The good point here is that you can deal differently between black noise, dark noise, and white noise. We separated those noise types in this phase. And the good trick is in this phase, I don't like to use a star reduction methods. They usually look kind of artificial. And narrowband filters, anyhow, they produce a very tight, tiny stars. But if you use, it's a very useful tool, as a tool. Let's pick up some problematic point here.
Jukka, what bandwidth have you used with your filters?
This is HA.
What bandwidth?
7 nanometers. It's a Barter filter set. So this is problematic place here. As you can see, here's noise. Well, you barely can see it there, but it's there. Then I select here the minimum filter and giving a 1 pixel radius. As you can see, it's make a huge difference. Too strong, actually. And then I pick here, fade the minimum. It's basically the same as you take a separate layer and use a transparency slider. And we give the value something like 25, 30. So all this very, very small noise is gone, but all the stars are still there. And let's say it's 32%. And to prevent weaker stars getting dimmer, as this do this, I add some sharpening, unsharp mask with quite a big radius, let's say something 20, and amount is something like, let's say 8%, so it's very tiny. And as you can see here, the stars get just a hint brighter when I do this. Let's see. Oh, I cancelled the whole thing, sorry. Let's say history, minimum, fade minimum, and now the slide sharpen, answer mark. It's 8% and a little bit 20 radius and OK. And now you can see it gives a little bit more brightness there. And also this is a good point to check that you have shades in every star. There shouldn't be any stars with the pure white, because then they are like holes. And check the levels. And it's a good sign. Here is a little gap between the full maximum size and the. If it isn't, you can artificially make some shades by moving output levels a little bit lower in the bright side. As you can see, the stars there getting a little bit dimmer. I usually cut about maybe 15 units from here. Okay, stars are here. Now the image. So this is the stretched image, but as you can see, when I remove the stars, there is no white really here. If I go to levels, I can see here's, actually there isn't. No, it's wrong image. Here. Let's see. Okay. I'll flat this down. Now. As you can see, now it's a huge gap here with empty space. I take the extra out, so the image is getting brighter, and then just adjusting the midpoint so it looks good. So nothing is burning, but all the information is now. And as you can see, there's a huge difference now, because there's no stars, you can do that. And of course, you are able to use curves and etc. to find a perfect balance here. And this is a very good place to make a copy of this starless version. And let's go see the noise. At this point, it's very good to have a noise reduction in the image, because you are not disturbing stars, only a dark noise and details. So what I usually do here, I'm using even a very simple method, Gaussian blur, but in a very small radius, something like 0.5 or like that. Let's find here some place where you can see the effect. As you can see, it's very close. This is 1, it's too much. 1.6, can you see what's happened here? It's making it softer. The dark details are smoothened out. But it's so small radius that it doesn't actually has effect to image sharpness, because it's less than a pixel. And now you have already a little bit smoother here. And of course you can use any noise reduction method you have used to use, like some noise ninja or whatever in this point. And now we can also use curves here, actually. Bring down some brighter parts and bring up some darker parts here. And you can see here those very, very dim parts start to come up here. And so on. And I like the tool in Photoshop, shadow and highlight. It's really useful if you learn to use it correctly. Here is the shadows and highlights. I zero them down like this. And now you can see the image here. If I set the highlights and the tonal width, I want only dim down the brightest part. So as you can see, what I can do here, it brings more contrast. I take it closer, so you can see now. That's the difference. And of course, the shadows, you can open up the shadows, but it seems here that it's pretty open already. And okay, we have done some smoothing and so on, so I can check here, this is good looking, something like this. And now sharpening, we do some smoothing, and now we do sharpening. And I call it local sharpening, because I want to control everything. We use the same starless image. We make a copy, and then usually I use a 3-4 iteration, depending what kind of seeing I have had when I took the original image. And I use here just a moment. Filter. Well, high pass here. I set the radius first, because the seeing was something like 3.5 at the time the image taken. I used a pixel size 3.6, a little bit over the seeing, and click here. It looks like a gray image, but actually it's not gray. There is some tiny high passed details, and I changed here. You can make it overlay. This is quite a strong effect. But I prefer soft light. It's give it a little bit softer. It's visible the difference. Can you see the difference in the image? Let's do so. I make it a little bit stronger, such that you can see it. I use the overlay method. It gives you a stronger image like this, and then I merge it down to this image. So this is the first state. Now I have image which all over using this overlay, this sharpening method. Let's see another point here. As you can see, it brings up the dark and high, but only also the noise. Now I duplicate this image and turn the first one mode to darken, so it's only dark parts are taken, and the second part I turn lighten. So now I separate dark, and this is white sharpening, and this is only dark boost in this stage. And now can I use opacity slider to think how much I want this effect here. Let's put quite a much dark sharpening and a little bit less white one. So, okay, now I'll have again one more duplicate, and I make one single layer out of this. But I want to put this sharpening in all over the image, so I'm using the layer mask. There must be a similar tool in Pixel site, for example. So layer mask comes here, and hide all. And now I can add this sharpening only to places I need it necessary. A bit more, and like here, and here, and here, and here, and so on. But remember, this was made by 3.6 radius, so it's bringing up the noise. If I want to take out a very dim, low signal noise elements in image, I do this again. I destroy this one. And it's the new high pass to starless image. And I put radius up to 50 or more. It's 65 here. And then to be sure that I'm not picking up more noise, I check this image and give it the Gaussian blur, let's say 1. Radius 1, which is quite much. And go back to whole image, and now I turn this to soft light, and you can see what's happened. It starts to bring out the very dim details and give an extra contrast to areas I like here, for example, without bringing any more noise. And of course I can select the effect, how much I want this effect, and using mask to put it somewhere else. And especially in this case, when you use a large radius, separation of the dark and bright sharpening is very useful. So I have make 2, change mode to darken, mode to lighten, and now only light parts are boosted. Now only darks. And then this is like this is not actual sharpening. It's like has effect to a contrast. It's a local contrast boost rather than sharpening. Because this is good point. This doesn't bring any artifacts in the image, but it's very easy to overdo. So let's give the dark boosts only 30% or less, and white boost a little bit more, let's say 75%. Okay. And if we bring the stars back now, here, and to be sure that everything is coming back, we are not using no filtering whatsoever. That's why there is a linear add, linear dots, linear add. It just calculates 1 to 1, click. And now you can see all the stars are here with the white noise. There's nothing missing. Yeah, if there was some white elements missing, they are also back here, some bright elements. And now, before we do any flatten or nothing, I like to use curves for the stars, because I can now do it separately. I can see now what I'm doing. So let's say I want to show more of the nebula. I can use how much weight I give the stars. They're all there, just the relation between the nebula and the stars is changing a little bit. Actually, you can have the same effect by using a very narrow filter. It's all a matter of taste, how you want to do it. As you can see, it's very powerful. You don't touch the nebula, you just only the stars. And well, this is like the basic function of star removal, what you do. You can stretch easily, you have more data, you have more control over different elements. You can make a noise reduction to white noise and black noise separately because they are very different, and so on. But I found out that it's so easy to overdo this. And that's why I always save the original normally stretched image. And at the end, I flatten this, and I take the normal image, which is just out of the CCD stack software. Maybe some slight curves is here, and put it top of it. And then I just took 50% off, whatever you've done. That's true, because you get blind. You make too effective sharpenings, too effective contrast boosting, and you only end up with an artificial looking image. But doing this has all the work, and you took 50% off, or 30%. But it pays, because it's really bring, all your work is there, but in a tasteful amount of it. So this is how my current workflow is doing at the moment. Another tip, if we take this image as it is, this is just a stretched stack. The simple way to do the same thing I just did, the complicated way, is use the noise filter, dust and scratches. Sorry, I make a duplicate of it. first. As we start for dust and scratches, but now I put a large filter radius, maybe 36, 50, and I destroy all the high signal noise elements, including bright nebulas. So it looks like this. And then I restore the black details, like this. Now we have an image with dark details, but no bright details whatsoever. And we subtract this from the original. I took it wrong, it's a HI copy, yes. Here. Now all the details are here, I remove. This is bright details, dark and stars are here. This is only a nebula. I can even use a larger radius if I want to bring out the really dim stuff. Maybe I should do it. I back off a little bit. I make an even larger radius for the dust and scratches. Let's put the radius to 100, almost 100 or more. 100 is the maximum. And we really destroy all the details here. And like this. And now we restore the black details as we did last time. Here. And we do the subtraction. It's a copy here. Now this is really nothing white details. And now we can use this again for the high pass. I use really big radius here too, maybe 90. Soft light. And you can see there are new details coming up, which are hidden by the brighter ones before. And of course you can also, let's do this. I don't want to put it in full power, 50%, like this. And now you can use, for example, curves or levels. Let's use curves to dig out the very dim information here. Like this. Now you can see, start to see totally new shapes here around. And of course, you can play with, try if it's, how is I add this as a lighten? No, it covers all the details down there, normal. And if I now bring back the bright details here, with linear add, you can see it's a totally different looking image. Merge down and you open up all the very dim areas here, which you cannot see, are coming visible. Pay attention to lower right corner. By using, what happened just now was that we give a processing step to very low signal noise elements. We remove everything else away. And of course you can do it opposite. You can give sharpening or whatever you want to do just for the high signal noise elements in other images. So this is basically talk about star removal. We are talk about a little bit wider thing. We are dividing image by its content, different level, and give different processing to different content because they are very different. You have to stretch strongly the very dim parts. You easily blow up the bright parts, and it's like a compromise. Now you don't have to make any compromises. You can take everything. You can eat a cake and save a cake in this case. Okay, and of course, if the same thing is done in every color, so we end up to have a color image, and thinking about play with the color levels. But just a minute, lose my voice. Next thing we look a little bit look about the colors, and my current imaging system is a double imaging system. I use my old Meade 12-inch with QHY9 camera. This is black and white, and then I have a piggyback with Tokina lens, 300 millimeter f2.8 lens with the color cam with QHY8. So I'm shooting the same target with the long focal length and the wide field lens with colors there. So I use ultra high contrast filter with color camera, and that filter is kind of poor man's narrowband filter. It's like a single shot narrowband because it let through about, if I remember right, 27 nanometers from HI alpha, and then O3. And O3 ends up mainly to green pixels, some of them is blue, and H alpha ends up to red pixels in the camera. So you have a big color image. And the good thing is that that filter brings the real star colors. It's made so that you have real star colors. So this is another sample. The same object here is imaged at the same time with that camera. This is quite short exposure because I just need a color for the stars and not bother about the image quality at all. Here's a close-up. You can see there's the star colors, awful looking stars because it was just for the color. And you can see here is the blue parts where is some O3 emission. And this is natural color picture basically. And I scale it to the same size as this one. Typically you try to use H alpha as luminance, but that's not a good idea. Actually, you cannot do that because.
How do you scale it to the same size? With Photoshop or?
Well, I did this in the Photoshop, but I usually use a CEDIC stack because it can just automatically scale them same size. But this was so simple, so I just drag it there and stretch it. I use a difference mode so I can see when the stars are overlapping. So it's you can do it so many ways. Like you do that all the time when you stack images. And if you have good stacking software like CEDIC stack can take any pictures in any scale and stack them nevertheless. Yes, I was talking about using H alpha alone as luminance. It's a little bit questionable because there is no information from O3 and S2. And some objects, it's so strong that you have a missing part. You have just a color but no shade, and looks awful. And it's not right. So, but in this case, where this is dominated by H alpha, and there's so little O3, especially in this B color image, so I don't do it now. Don't tell anyone, because I always say that you have to do it, but I won't do it now. Let's see what we are doing. There's so many pictures open here. Get lost. Yes. Let's see, do we have a starless image here? Or did I destroy it by accident? No, I think I destroyed it. Let's see if we can go back. Yeah, no problem. I do it again in no time. I saw how to handle colors. Let's use this one. I don't need them anymore. No, I meant to get that. Okay, I make a very quick star removal of this image. Very quick and dirty. Actually, it's very easy to build Photoshop action from things like this, so I don't really do it like this every time I'm working at my home. That's my final step. Okay. Final cleaning. Just remove those few brighter spots. This is not necessary actually, but I like to do this. And now the subtraction to have only stars. What's the name of this image? Subtract and H. Yes. Okay. Now we have stars and nebula again separated. And then we have this image here. We do the same thing here. Like this. And I destroy stars from here. I need to give quite a big radius because it's so much upscaled. Let's send something like this. Okay, good enough. Maybe I just fix the blue star there because it gives too much color. And then I usually use, for color channel, I use median command, like quite big radius, like 11 in this case, because this is so small scale image compared to, this is something like 5 arc seconds per pixel, and this is like 0.75 arc seconds per pixel, so I can use large colors here and some smoothing, so I don't want to add color noise. So by avoiding that, I use here some smoothing. And then the stars. This is the black and white image, so I turn it to a RGB image like this, and don't flatten, duplicate it. This is now color image, and I bring this image which has stars, which is scaled at the same size. As you can see, the stars are same spot, both images. And as you can see, there is not much stars, not much color here, but I turn this to a color channel like this and merge it down. Now you can see that there is stars in the start to be colors, but it's very difficult to see because stars are very tiny. So what I do, I use maximum, I duplicate this layer, I use maximum filter. It's very useful, and let's say quite a big radius, like 15. Now I can see the star colors. I couldn't see them before. I can see there's a purple stars, which I don't like. There's red stars, which are not correct, and some other colors. So I use usually curves. Of course, it's easy way. Or you can use selective color changing here. Like reds, I like them to be less red. So I turn them to more or less orange, like this. And then I see there's magentas. I get rid of them, as you can see. There's no magenta anymore. And then I don't want the dark blue stars. I want more or less turquoise stars like this. And then I add some saturation to here. As much as I like. I do it a little bit over now so you can see. And then I turn this to a color. Now I have nice colors with my stars here. And I flat it down. And if I use this, by the way, it could be nice looking to have colored stars and a black and white picture. I've never done it. Let's see how it looks. Oh, this was black and white picture, of course. It doesn't bring colors. I had to change this to color image too. Like this. And now I bring the stars there. And let's go to see close image. As you can see, there's now colorful stars in a black and white image. Looks kind of odd. Okay, take it away. And now the color of the nebula. We bring this image here and use it as a color. Now we have typical salmon color with you use H alpha and RGB color together, but that's not the problem. Because the red color it's a problem thing for a couple of reasons. It acts quite differently than other colors. It's difficult also in printing technique, and in televisions and digital media generally, red color is always problematic because it has a strong internal brightness. So you have to dark it down more than other colors. Otherwise, it's overwhelming in image. And here it makes it blue. But you can see there is some blue shades here. So what I'm doing first, I took curves and dimmed down the whole image. Here. Don't want to lose the background details, but bright parts, because red has internal brightness. And then I use, again, selective colors, where can I add some more power to red color. As you can see, it's less and less salmon pink. And then I'm going to use just a simple saturation here. Add to more color power. We are getting there all the time. I can control the brightness here. It starts to look not anymore so salmon. I have a deep, nice red color. Unfortunately, this so light room, so it has a very little contrast. But believe me, it's good looking red. Then curves again. I want to bring out here some details. I use this pipette to see in what part of the curve it belongs. It shows the small box there. I want to dim down that part. Like this. Now we start to have good colors, and there is a nice blue from OIII in the middle. I like to boost it a little bit, so I use curves. I select only a blue. It belongs there, so I raise the value a little bit, but keep the background neutral. Okay, now I have a more blue there, as you can see. Start to look like astropics. And then I bring the colorful stars at top, with missing details if there is some, and use the linear dots mode. So now I have beautiful tight stars with beautiful color and practically noiseless image with a lot of details and deep colors. And this is done by using a color information for very low resolution image. Of course, it's better to have same resolution for colors than, or at least bin 2 or something like that, but it can be done. The information is there, only the resolution is different. And as you can see, the colors, the star colors here, if I want, I can now change, because stars are still in separate layer here. So I can more fine-tune the colors, very peaceful. And as you can see, if I have, let's say, RGB stars, it's as easy as this to put the star color there without any colorings, or is typically caused by using a color from a lower resolution. You have ringed stars and some ugly details. And now this is basically why I'm doing this, to have control. As a control freak, this feels good to know that I'm not depending on any accidents or happenings that happened to happen the image when I change the curves. Now I know I don't ruin my stars. I have people ask why you have so small stars. Are you using the stars suppression or something? Only thing I'm using in the raw data, the raw stack, is maybe 20 iterations of deconvolution, and I use that only with 50% weight, so it's very tiny. It just bring up some. The reason for that is that when you have a bad seeing, very dim stars get lost. But by using a light deconvolution, it brings them back. It doesn't actually affect the larger stars, but only the very dim ones. It can calculate them to tight to be visible. Sorry, I need to drink water. But you can ask now if you have this. What?